Okay. Um, let's see. I guess number one is the fact that we have class today and we have class Thursday, and that's it. That's all, folks. Okay. Now, with that in mind, let me remind, and this is not just for you but for everybody, research papers were technically due in sometime today. I'll accept them later, but they technically were due today because technically Thursday is final exam day, which is when I'll be giving you the last chapter test. It's not going to be comprehensive, it'll just be on chapter 4, but I really can't give it before because I need to see how far we're going to get approximately, and then I'll have that and send it to you shortly after class ends, probably in the afternoon on Thursday, because I have a class right after this one, a linear algebra class right after this one, but then I have a couple hours in the afternoon on Thursday afternoon, so I'll post the test then. So that means please get your research paper in as soon as you possibly can. You've already turned in test 1, and I don't, wait, no, have you turned in test 1? I have a mark in my thing, but it looked like I scrubbed it out. Yeah, I think, have I received your test 1? Yeah, okay, okay. It may be I just haven't gotten it graded. Let me see if it's in here. If I acknowledge that I received it, then I have it. There's Ricky. Wait, this is test 2. Okay, let me see. Yep, there it is, test 1. All right, good. And let's see, test 2, was that the same thing? Yep, I got test 2 also. Yeah, I just haven't gotten them graded. I don't know if you can see this many papers came in, I think, last week and this week, and I got about half of them graded over the weekend, but didn't get to this class. So I have 2 really big classes, and one of them has had 8 labs and 8 tests so far, and in 8.5 weeks, that's kept me hopping. So I'm behind on grading. I'll try to get those done soon. So and that's what I'm going to use office hours today for. Luckily, knock on wood, I still don't have any advising appointments today, so hopefully I'll have some time this afternoon. But right now, I'm still printing off stuff that came in over the weekend because I was out of town this weekend, and we were at a place where the internet was miserably slow and unreliable, and also we didn't even have a printer, so I couldn't print anything there anyway. So that's why I graded, because I couldn't print. Um, and So I will try to get caught up with grading and maybe even get things out on Blackboard. So please get your research paper to me today if possible, but as soon as possible otherwise. And then you've got first and second test turned in, so I'll be giving you the third test, and that will be on Thursday afternoon probably. So, and then grades have to be due, or I think grades are due in by noon on Monday. So that means you have Thursday, Friday, Saturday, and no later than Sunday to get that third test into me. If you can get it to me Thursday, fantastic, or Friday, excellent. Saturday, okay, but Sunday, I have to have it by Sunday because I cannot be grading, 5 classes worth of papers on that get turned in some Monday morning and still get the grades on Blackboard by noon. Yeah, so please, if you can, get the paper to me as soon as possible, and then the test as soon as you can after I get it to you Thursday afternoon. All right, any questions, issues, concerns, problems? Okay, well, let's pick up, and here's another thing, and I'll say this on here. You're here, obviously, okay, but yesterday, let's see, me get my timeline right. Yeah, yesterday I had that afternoon class, big class, and there was one guy who's usually there that wasn't. I thought, well, something just came up. But then this morning I saw an email from him that he was trying to get he didn't get the invite, and I would have thought freaky, but nothing about it, except that this morning before I saw his email, a woman from my linear algebra class that starts at 11 o'clock this morning, she said she didn't get hers, and I went back and checked. Now I know the other folks, or at least some of the other folks, got theirs because they were in attendance yesterday at his class, and I went to check, and sure enough, it's right there on Blackboard. She sent her email at 10:40 last night, and I sent the thing out between 5 and 6 yesterday. So I don't know if that's why. I know Melissa's has a doctor's appointment, but I don't know the others. I can't tell now. I don't know if Blackboard's screwing up, which it has in the past, or if Zoom, I don't see how it could be Zoom's fault because I put it out there on Blackboard. But that 2 people in 2 days said they couldn't, and there may be others. So anyway, that's for folks who are out there. I did send it. Cole and Melissa are evidence that it was out there on Blackboard, but if it wasn't in your box, I don't know why Blackboard. I send it to everybody. It says all class members, and that's who I send it to. So anyway, let's pick up and go from there. Now I don't know if you can hear me now, but I have a message on my screen saying my internet is unstable. Did I get scratchy, or did I check out then? Okay, all right. Well, so my wife said the internet was not stable yesterday, and I had that same. In fact, another time yesterday, I can't remember which class that was. I think it was my first class. Zoom just shut down in the middle of it, but it looked like my internet was good, and but then the internet went out too. So and it was just, I probably lost 5 to 10 minutes of class time trying to get everything up again. I changed providers, I did all sorts of things, finally got back on. So if something like that happens, hang on, I'll be back as soon as I can get it to come back. All right, now you weren't here last time, so you probably didn't get to see what we did in example 3. And I was going to pick up where we left off, but since you weren't here, yeah, it's not going to take that much to go back and do this, because this is a very good example showing a variety of things that we have to do. So we're in chapter 4, which is higher order differential equations. This happens to be a second order that we're dealing with here. In section 4.4, which is undetermined coefficients superposition approach. That's what we're doing, and that's why they say this. Now, here is the differential equation, okay? And you can see the text here, can't you? Okay, good. Y double prime minus 2y prime minus 3y is equal to 4x minus 5 plus 6x e to the 2x. Now, the first part of this, and I'm going to go to the whiteboard so we can step through it all, but here's the way we do this. We take the first part, the part with the y's and the y primes, everything dealing with y's on the left hand side, and set the right hand side equal to 0. Then we do what we did in chapter 3, solve a homogeneous equation, and that's where we get our arbitrary coefficients. Okay, we'll go back and do that. Okay, then we start working on the right hand side, and we come up with the y sub p, which is the particular solution, and we make what they say is a little bit more than an educated guess at what it would be, and then we go from there. So let's go to the whiteboard and just quickly go through. I say quickly, I don't do much of anything quickly, but I'll try to do this. Now, it has a taskbar that I need to move to get out of the way as much as possible. And now I'll also move the whiteboard screen as much as I can to get as much white space as possible. You probably can't see the taskbar, but can you see the whiteboard moving some? Just a little bit? No, okay. I've already quit, so you wouldn't be able to tell now. Okay, you didn't notice it moving. Yeah, all right. So let me pick up and go from there. This is example 3. Let me get the book in my lap. And I can't remember if you were here or not when I had first got the Wacom. That's a writable tablet, so it makes it a lot easier to write than writing with my finger. Okay, so here is the problem. Y double prime, it's still not perfect, but it's better, minus 2y prime minus 3y. Now, is this statement here that's please move this window away from the shared application? Do you see that? I do. Okay, so I'm going to have to go below that, okay, is equal to, I thought it was going to fade out and quit, but it didn't, is equal to 4x minus 5 plus 6x e to the 2x. Okay. First step is to do the homogeneous part, the left-hand side. Y double prime minus 2y prime plus or minus 3y, set it equal to 0. And that will give us what we call the characteristic solution. Okay? Now, the assumption here is that y, as we did in chapter 3, is equal to some form of e to the mx. Okay? That's going to work here, and this will be the characteristic part, y sub c. Okay? If you do that, and we did it many times in chapter 3, you know you'll come up with the auxiliary equation, which is just this m squared minus 2m minus 3 is equal to 0. Okay? Now, it would have had an e to the mx in it as well as a factor of all those. We factor that out because that's never equal to 0. This is what we solve. And this, hopefully you remember from your factoring, can be factored as m minus 3 times m plus 1. Okay? And that's equal to 0. Okay? Now what that gives you is that either m is equal to 3 or m is equal to minus 1. Okay, go back in and plug it in here. That gives your characteristic solution. Y sub c is equal to c1, arbitrary coefficient, e to the 3x, plus c2, some other arbitrary coefficient, e to the minus x, when you put the minus 1 in there. Okay? All right. Ringing bells, make sense? Okay, good deal. So there's your characteristic solution. We're through with that for right now. Now we'll go and see if we can figure out what to do as far as a particular solution. Y sub p. Okay. Now that's dealing with the right-hand side. The first two terms here are all polynomial. Okay? So let's assume that then we would have, and this is only first order, first power, first degree, so we don't have to go any higher than that. So we'll assume that ax plus b will take care of that part. These are undetermined coefficients. If you ever figured out why they named it undetermined coefficient, these are they. All right, now the second part, we notice we have a polynomial multiplied by an exponential. Okay? So therefore, our particular solution, and remember this too. If you had okay, what we're going to do, the next step after we do this, if I can get my thing to work, is to plug this, take the first and second derivative of this particular solution, put them back in the original equation over here, and go and see what they get and see if we can produce this on the right hand side. Okay, because this is a product rule here, when we are going to take the first and second derivative, you know you'll wind up with xe to the x's and e to the x's, if you think about how the product rule works. So therefore our solution here must include, or our educated guess of a solution must include some c x e to the 2x, but it also must include a term with just e to the 2x in it, with no x. Now, this book, because they love using that differential operator, capital D, they avoid capital letter D. So they go straight to capital letter E. They skip D. So we'll do that too, just so we'll be the same as the book, and this will just be e to the 2x. That's an ugly 2. Okay. Now, that is our guess of a particular solution. This part will give you your polynomial part. These two parts will cover this part. Okay, so the next step is to take your derivatives. Y sub p prime, and that will be, you want to tell me or you want me to do it? Okay. Derivative of ax is just a. Derivative of b is 0. Okay, I could do that one. Now, the next part has a product rule that we were talking about before. So we know it's going to be c. We'll put that in front. Okay, product rule usually goes first times the derivative of the second, so let's do that. X times 2 e to the 2x. Agreed? Okay, plus, now the second part of the product rule is the c. I'm going to write that down. Okay, and it's the second times the derivative of the first. So the derivative of x is just 1, and that would be c e to the 2x. And that's the part that we knew was going to pop up in there. And then the y prime of the last part is just going to be 2 capital E little e to the 2x. Okay, 2e to the 2x. Agreed? Yes. All right. Now, I don't know if it's worthwhile or not, but probably just as good just to go, even though we have some terms we could combine, let's just go on and do the second derivative, and then we'll do combining when we need to. Okay, so y sub p double prime. Okay, the a goes away, derivative of a constant is 0. Now here we have that product rule again, so I'm going to put, I'm going to be a little smarter this time, since we're going to do first times derivative of the second. I know we're going to get another 2 there, so that's going to make it 4 c x e to the 2x. Was that too much a sleight of hand, or did you follow that? Okay, good. I'm going to get rid of this book. It's a pain in the neck. Okay, that's the first part of the product rule. The second part, if I can get my pen to show up again, there it is. Okay, will be, this time it's just a plus 2. Derivative of the first is 1, and then just write down the second, 2c e to the 2x. Okay, here's the part that we could have combined these together, but I just thought let's keep them separate for now. And derivative of this one would be another plus 2c e to the 2x, and I think I'm going to erase that and just make this 4 because I'm running out of room to write. Okay, to do that, see, this is 2ce to the 2x, another 2ce to the 2x. I didn't even finish writing that. Let's just make this 4ce to the 2x. That will cover both of those. Okay, the one from here and the one from here. And then the last one would be a plus 4 e to the 2x. That way I can get it all in one line. All right, now we write down, plug these forms here into this original equation here. So the y double prime we write down. Boy, this is going to be some writing too. That's going to be 4cx e to the 2x plus, now this time I think I will combine terms because I don't have that much room. So I'm going to do c plus 4. Now, didn't I just say I was going to double that? And I don't see that it showed up. When I took the derivatives here, that was a 2c e to the 2x, and this gave me another 2. This is supposed to be a 4 here. And I thought I wrote it down, but maybe I didn't. This is scary. Okay. So that's a 4c here. I'll have to check and make sure I haven't botched something here. Plus 4e e to the 2x. Okay. Minus 2 times your y prime. So that's going to be a minus 2a, a minus 4c x e to the 2x, and I'll go on and combine these two together again. This time it's going to be a plus, no, it's going to be a minus. Okay. Okay, because it's a minus 2 times this term. A minus, I think I'm going to put this in parentheses too. 2c plus, or yeah, okay, it's in parentheses, so that's going to be, that's one reason I don't like to group them, because the signs will wind up screwing you up. But 4e, and that's times e to the 2x. Okay, so that's minus 2 times your y prime. And now we still got our minus 3 times your y. So that's minus 3ax minus 3b minus 3c x e to the 2x minus 3e e to the 2x. All that mess is supposed to equal this mess, 4x minus 5 plus 6x e to the 2x. Agreed? Okay, good deal. Now, what we do is start picking this apart. And I really don't care where you want to begin. We could begin up here with the x e to the 2x terms and go from that. Or we could start down here and start with the x terms, or we can start anywhere you want to. Do you have a preference?
X.
Let's start with the x. That seems a little easier. So let's do all the terms from up here that have just x. Okay, these have e to the 2x's. That doesn't have an x. This doesn't. That doesn't. Struck out on the first line. Here we have a minus 3a. I don't know where to write this. Let's write it here. Minus 3a. And that is the only one. That has to equal to 4 because the only term with x in it on this side is 4. So you see we're just equating this coefficient to this coefficient, right?
Yes, sir.
Okay, so that produces capital A. We've just determined our first coefficient, minus 4/3. Okay, before I go much further, I want to make sure the book got it right, and they did. Good for them. Okay, where do you want to move next? We have the e to the 2x term, the e to the x term, the x e to the 2x term, the e to the 2x term, or the constant term. Uh,
Do X E to X.
oh wow, I thought you were going to go for the constant, but that's fine. We'll go with that one. Well, it is a little shorter and easier. So let me do this too, just to acknowledge that we've wiped out that term and we've wiped out this term by our a over here. So let's do the constants, okay? Here we have a minus 2a on the left. That's a constant. And a minus 3b on the right. I mean, it's still on the left. And that's all. And this is supposed to equal a minus 5. Okay, but we already know what a is. A is minus 4/3. So this is going to be a plus 8/3 minus 3b is equal to minus 5. I'm going to do some monkeying around with that and move the 3b to one side. So we have 3b, making it positive, and then move the constants to the other side. That would be 8/3 plus 15/3. So I think that's going to be 23/3, right? Okay. And then divide by 3, and this produces b is equal to 23/9. One of my favorite numbers of all time. Okay. Let's make sure the book got it right. Good for them, they did. Yeah, good. Okay, I thought they had a minus there for a moment. Okay, so we now have our b. Okay, we've done the easy ones. Now you were saying let's go to the e to the 2x's. And I'm afraid I may not have room for all this. So what I'm going to do is get my eraser active if I can. Okay, there we go. And I think the best bet will be for me to wipe out probably this, because we've already used that and come up with what we needed. And I don't want to lose the result of this, but I can lose what we're using to get to it. And the result is b is that, so I don't want to lose that. I can lose all this, but I don't want to lose the result. The a is that. And then I think I can lose just about everything else. No, I can't lose that. Sorry. This I can lose. I hope. Now, if I made a mistake, you'll have to find the error because I've already erased it all. Okay, that's the method to my madness here. Write big so I can write, and then say, and the rest is left to the student, you know. Isn't that how most calculus books operate? they skip steps like crazy and say, and the student, it's obvious, intuitively obvious that this is true. Okay. Now, okay, now I didn't wipe out. I wiped out this one and this one. And did I wipe? I wiped out the right hand side. Well, here it is. Sorry about this. This is equal to, why didn't you stop me? 4x minus 5 plus 6x e to the 2x. Okay, now you want to do the x e to the 2x terms next. Is that right?
Yes, sir.
Okay. So, what we have here, and this is almost a whole new bag of worms here, so let's start with it. The 4c x e to the 2x, so I'll go on and wipe that one out. This is just e to the 2x. Here's another one, minus 4c. I think I can handle that. That adds to 0. Okay, so I've taken care of that term. And this is just e to the 2x. We don't get, oh yeah, right. Here we have, right here. Here's a minus 3c. Okay. That must equal 6. This is working out easier than I thought it would. This implies that c has to equal -2, right? Okay, let's see if the book got that right. I believe they did. Okay, good for them. Now the e to the 2x terms. Okay? I'm going to wipe out, I wiped out this one. I did put that minus 5. Yeah, I had to have. Okay. And then this one. Okay. So we don't have an e to the 2x term on the right hand side, so that means whatever is on the left is going to equal 0. Okay, now I'm going to split these apart again. Here's a 4c plus 4e okay, that takes care of that one, minus 2c minus 4e. That's interesting. Okay. Okay. Minus 3e. That's it. Has to equal 0. Okay. So let's see what we've got. We know what c is, a -2. So here we have 4c minus 2c is 2c, but c is -2, so that would be a -4. Agreed? Minus, I've taken care of that term and that term, minus 3e is equal to 0, which implies for us that e is equal to another -4c, 4/3. Is that right? Yes, it is. Okay, good for this. Okay, so now we're ready to write our solution if we can find a place to do it. Your general solution, y, is equal to your characteristic solution, this one, c1 e to the 3x plus c2 e to the minus x. That's from the characteristic equation, plus the particular solution, y sub p, and that's going to be, oh man, I did erase it, didn't I? Okay, you have to remember that was a minus 4/3. That a was the coefficient of your x term. Your b was the coefficient of the constant term, or was the constant term, plus 23/9. Okay. The c was the coefficient of your xe to the x. Okay, so that's going to be, if I can find where my c wound up, -2. That's minus 2x e to the 2x. And then your e was the coefficient of your e to the 2x. So that's going to be a minus 4/3 e to the 2x. All right, stuck in there somewhere, there's our total solution. All your arbitrary coefficients, and you have to have at least as many as the order of the differential equation, 2. There we have our 2. All those come from your left-hand side, from the homogeneous part, from that characteristic solution. Your undetermined coefficients, which we have now determined, they fill in the blanks here. Okay, and you cover every term. Now let's see how the book did. Okay. I'm trying to see if they ever come up with a solution. So far I haven't seen it. Oh, there it is. There it is. Okay. So y is equal to c1 e to the minus x. They wrote that in reverse order. Plus c2 e to the 3x. I did them reverse, but you know, they're arbitrary coefficients. They could be anything. Minus 4/3 x plus 23/9 minus, and then they split out the 2x, and then because the minus is on the outside, plus 4/3 e to the 2x. Yeah, you could do that. Do you want me to write that out too, or are you okay with the way we wrote it? Okay. All right, good deal. Any questions on that? Pretty good synopsis of how these things work. The last example, and no, an earlier example, it seems like, maybe we haven't gotten there yet. I thought we had one that you had to introduce yet another wrinkle to the, oh, here comes Dawson. Okay, let me see if I can find my cursor to let him in the class. Did you want him in? I didn't ask you if you were in favor of that or not. Okay. Okay, bottom half of the alphabet, which doesn't only goes through M here, they're all here. The top half is missing completely. So now I know Billy emailed me yesterday that her internet had just gone out completely and she was going to have to get a new modem in and would be back in class on Thursday because she wasn't going to be able to be with us at all. I know Ricky has lots of issues at home. I don't know if you were here when she told us that her dad has COVID-19 and she's the caregiver because her grandfather has it and her mother is taking care of him. So she's got a full plate right now. Okay, Dawson, welcome. You here yet? Okay, good. Just a little bit of a review. I set it to Cole, and I think, and it's being recorded, but let me just say it again. I need research papers in. I would prefer them in today. This was supposed to be the last day they were, you could get them in without losing points, but please get them in today if possible. If not, as soon as possible. Okay, first test. I can't recall if I got your first test yet, but if you haven't sent that, please send that one. And your second test, okay? So please send that. And those will be, I need those before Thursday, if at all possible. I would like to have your research paper today if you could get it to me as soon as you can. Otherwise, the two tests, if you haven't turned those in, let's get those to me before Thursday if possible, because Thursday I'll be giving you the third test and you only have a very short window to work on that one. It's going to be, I'm giving it to you Thursday afternoon, and you'll have Thursday, Friday, Saturday, and please no later than Sunday to get it in. If you can get it to me Thursday afternoon, I'll be so delighted, okay? If you can get it to me Friday, that will be fine too. Saturday will be okay. Sunday is just about the last gasp because I have to have grades in, I'm almost certain, Monday morning, Monday at noon. So I can't be grading everybody's last paper or test, everything that gets submitted, and I don't get it until Monday morning. No way I can get everything graded, grades averaged in Blackboard, averaged, and then posted your grades. So if I don't have it by Monday morning, there's a good chance it will be an incomplete. And then as soon as I get it and get a chance to grade it and get the grades in and everything, then I'll change the incomplete to a letter grade. So please try to get the research paper to me today, if at all possible, as soon as possible if you can't get it to me today. And then the test, both tests, if you haven't turned those in yet, by Thursday if possible. So you can focus then the last couple days on working the third test. All right, any questions? Okay, now we just finished working example 3, and what I'm going to do is clear. Okay, Dawson, you need this up a little longer. Are you okay watching on YouTube video? Okay, go on and clear this, if I can find it. There it is. And go back to my screen sharing and go back to the book. All right, and this was how they did the problem we just did. The first step is take the left-hand side, the side with all the y's on it, y's and their derivatives, set that equal to 0, make it a homogeneous equation, and find the characteristic solution which contains your arbitrary coefficients, C1 and C2. Then we deal with the right-hand side, and we know that the 4x minus 5 is a polynomial. The most reasonable expectation is for that polynomial you'll need a ax plus b. So that's your first part of your particular solution. The rest of the right-hand side is a mixture of x times e to the 2x. Okay? Now, a term with that in it is going to have an x e to the 2x in it when you take its first and second derivatives, but it'll also produce a term with just an e to the 2x with no x in it. So that's the second part of our arbitrary coefficients. Is the second part is going to have to be cx e to the 2x, and this book doesn't like to use d because they use the differential operator, which is capital D, so they jump to e to the 2x. Now that's not e, but it's capital E times the exponential function raised to the 2x. So that becomes our particular solution. Okay? Then we take this particular solution with these undetermined coefficients, a, b, c, and e. These are not arbitrary. Okay? They come from plugging this particular solution, taking the first derivative of it and the second derivative of it, and plugging that into your left-hand side. So when you take and we went through this, you'll have to go back and review that. But we did that, and then they group all the terms together, not like, because they knew what they were going to be, but, well, no, they didn't. Okay. When they take the derivative, and I'm not going to go through all that again, but this is what you wind up. These combinations here then have to equal the right-hand side. When you put in your proposed solution, first and second derivatives of them, plug those in here for this equation, it's supposed to equal the right-hand side. Then you match your coefficients. We saw that minus 3a had to equal 4. So that gave us our a here. that minus 2a was supposed to equal, no, minus 2a minus 3b was supposed to equal 5, but we already had figured out what a is from the first one, so we were able to get the b from the second one, and then the 3 minus 3c x e to the 2x has to equal positive 6x e to the 2x, so obviously c has to be a minus 2, okay? And then this one right here has to equal 0, but we already had figured out what c was, a minus 2, so you can determine what e is. And that's exactly what they did, and we did. They gave the a was equal to negative 4/3, which I just described here. Plugging that in, you got b is equal to 23/9. C, as I just described, is going to be a minus 2. And plugging that into this, setting it equal to 0, that gives you e is equal to minus 4/3. So your particular solution then, with these values in for your a, b, c, and e, you have minus 4/3 x plus 23/9 minus 2x e to the 2x minus 4/3 e to the 2x. Plugging that in to your right-hand side, adding that to your characteristic solution, which was this one, and then adding that to it gives you your general solution, y. Now they did group these two terms together, pulled out the minus. They could have pulled out a minus 2. I don't know why they didn't do that, but pull out the minus, and then you get a 2x plus 4/3 e to the 2x. I don't know why they did it, but they did. It's perfectly legal in most states. Okay. Now, they gave another way of doing, which is exactly really what we did. We did this part with that part and this part with that part. It's the same deal. You get them all together and add them together. Whoa! I don't know why it did that. Get rid of that. Okay. All right. Now, the next example illustrates that sometimes the obvious assumption of the form of y sub p is not the correct assumption. Okay, they call it a glitch in the method. It's just reality, okay? No glitch, it just happens. Okay, now, it seems like did I put my thing in the wrong place? It seemed like we did this one last time. I thought we had done the previous one. I've taught this course so many times, maybe I'm just remembering wrong. Maybe I put my paper in the wrong place. Were either of you here last time and remember that we had done this? Okay, Dawson, that was you? Or was that Cole? Cole was not here. Okay, alrighty. Well, let's go on and do, because I was thinking we did this one before, but let's see. Okay, because this one, the reason I said that, it just says find a particular solution. It doesn't say find the other side, okay? But they snuck this in on you, okay? If they had done the left-hand side, then you would have seen this. And so let's go on and do it the way it should be done. Let's do both sides. Let's go to our whiteboard. They're making it seem like there's something nefarious afoot, and it really isn't. Here's what the problem is. Yuck! That probably was me. Okay. So, find a particular solution. We're going to find the whole solution for y double prime minus 5y prime plus 4y is equal to ae to the x. Okay, there's our problem. Now, they just said find the particular solution, and when they go about trying to do that, and it's a pretty easy process, they found out it doesn't work. And that's why they told you just do the particular solution. If you had done the characteristic solution first, which you typically would have, you would have seen why it wouldn't work, okay? But they make it like a big discovery. Well, let's go on and do it. Now, let's just save some room. Can we go straight to the auxiliary equation? Or would you rather have me write out all? The assumption here is y is equal to e to the mx. You remember that, right? So let's go straight to the auxiliary equation. That would be m squared minus 5m plus 4 is equal to 0, because we are doing the homogeneous equation ignoring the right hand side. And of course this will fortunately factor, and this factors as m. Goodness, this drives me nuts, them doing that. M plus 5 times m minus 1 equals 0. You can check that out and see it, which means, of course, m is equal to negative 5 and m is equal to 1. So your characteristic solution, y sub c, is equal to c1 e to the minus 5x plus c2 e to the x. And this is why your procedure that you would normally do won't work, because you see any number c e to the 2x here is going to make this true. So you plug that in here and you're going to get, my pen is not, there it is. Plug it in here and you'll get 0, not 8e to the 8e to the x. So that's why you can't do that. You can't merrily go on your way and just say that's your arbitrary solution, some ae to the x, because you've already got that covered in your characteristic solution. So just like we had to do when we had repeated roots to roots, you have to plug in. So your y sub p here, you can't just say ae to the x, okay, because any ae to the x is going to work. You're going to need an ax e to the x. Okay, now the question is that the only one you need? And the answer is yes, because if you put the be to the x, that's going to be the same problem here. That always works. So the b is going to wind up being 0. So there's your particular solution here. Now what do we do with it? What's the Jesus answer? You take a derivative. Y sub p prime is equal to, and now you got a product rule here, ax e to the, yuck. Okay, it'll go away in a minute. Ax, my pen needs to come back though, ax e to the x plus a e to the x. Product rule, right? My nose is itching. Must be going to have company today. I hope not. I don't think so, not with COVID. Okay. Now, if I get the pen to come down here, we need also to do our y sub p double prime, which will be ax e to the x plus another ae to the x plus another ae to the x, so that's going to be plus 2 a e to the x. I did that rather fast. Was it too fast? You okay with it? Okay. Now let's plug that into our original equation. The y sub p double prime would be a x e to the x plus 2a e to the x minus 5 times a x e to the x minus 5 times a e to the x. That's multiplying the minus 5 times your y prime. Okay? Then we do plus 4, running out of room again, plus 4 times y particular, which is just 4. I could have gotten all that on there. Let me go on and erase. I'll write it on the other side. Okay. Plus 4 a x e to the x. Okay. And all that's supposed to equal 8 e to the x. This is those things plugged in here to the left hand side, and then your right hand side is that. Okay. Now obviously there is no x e to the x term on the right hand side, so these had better add, and let's take a look at them. If I can find the pen, there it is. Here's a x e to the x minus 5ax e to the x, that makes minus 4, plus 4ax e to the x. Thank goodness that adds to 0. Okay, so all we have to do is 2a minus 5a, which is a minus 3a. Why am I writing it down? Yuck. A minus 3a has to equal 8. Plus 2a e to the x minus 5a e to the minus 5a e to the x will be a minus 3a e to the x. That's equal to 8 e to the x. So minus 3a must be 8, which implies, of course, that a is equal to minus 8 thirds. Okay, so what's your solution, your general solution? Y is equal to your C1 e to the minus 5x plus C2 e to the x plus your particular solution, which is now a minus 8 thirds x e to the x. Okay, there it is. All right, and all they were looking for is a particular solution, which is this. That's all they were looking to. Y sub p is equal to minus 8x e to the x. All right. So they give two cases here, just like they did back when we were doing the homogeneous equation and solving it. But case 1, no function in the assumed particular solution is also a solution of the associated homogeneous differential equation. In other words, part of the characteristic solution. Okay, if that's the case, you just write them down. Okay, you just put them down, then they go with it. Okay. And Okay. Case 2 is the bottom of the next page. So we're going to focus on the case 1, which is up until this last example, that's what we were focusing on. But I don't want to write all these down. I hope you have your books. Well, wait. I have the text here. So let's go back to the text. All right, to clear? Sound like an ER room. Clear? Okay, done. Okay, let's go back to the text. And this is what they were saying. There's your particular solution. We plugged it in, saw what we got, and came up that minus 3a e to the x equal to 8 e to the x. So a is equal to minus 8/3. That gives us our particular solution. That's really all we were looking for, but why not write it as y, the general solution, would then be your characteristic solution, c1 e to the x plus c2 e to the... Did they get this wrong? I got it wrong. Sorry about that. Those are both minuses. I must have written it wrong. Sorry about that. It's the x minus 4 times x minus 5. No, x minus 4 times x minus 1. But it came out the same. I'm sorry, I did the auxiliary solution wrong, equation wrong. C1 e to the x. That's the one that's the problem here, because that's what your right-hand side is. Plus C2 e to the 4x, not a negative 5x. I don't know where my brain was. Okay, but anyway, got too clever for my own good there. But anyway, that's that, and then add to this, and you see it wouldn't have made any sense to just have a e to the x here, because you just combine the a with the c1, you got another c1. That doesn't produce a solution. Okay. But now we go down here and say, okay, let's say that doesn't happen. Okay, if it doesn't happen, that the no function, the assumed particular solution, is also a solution of the associated homogeneous differential equation. In other words, looks a lot like, in the sense of almost identical to any part of your characteristic solution. That's what it's saying here. Now here are, I don't know why the writing is messed up here, but it is. This says a trial particular solution. So the TRIA and the L is printed here, and there's a P for particular. PA is printed there. I don't know where the R is. Okay, particular, and there's the L. A and the R, I guess, is in here. I don't know. And solutions, there's the S. I guess the O's in there, and maybe the L's in there too. I don't know. Boy, that's messy. Thank goodness they didn't mess up the table part. They just messed up the title. So, if your g of x, if the right-hand side is any constant, then your particular solution is just going to be the arbitrary constant a. Okay? Arbitrary a. Anything. Okay? I mean, not arbitrary. Undetermined a. If it's a linear polynomial, it's a linear polynomial, ax plus b. If it's a quadratic on this side, now even though this quadratic only has 2 terms, you have to include all the possible terms of a quadratic here. Ax squared plus bx plus c. If it's cubic, same deal. No matter how many terms it's got here, you have to include an ax cubed plus bx squared plus cx plus e. They leave off, they don't use d. Now, if it's a sine of any nx, it doesn't matter what it is, then your y sub p would have to be the cosine of that same nx, so with some undetermined coefficient, a cosine, say 4x or nx, plus b sine 4x or nx. If it's a cosine, same deal. You have to include both sines and cosines, because when you start taking derivatives of sines and cosines, you're going to introduce the other one. If you take derivatives of sine, you're going to get cosines. If you take derivative of cosine, you're going to get sines. Okay? But when you take the derivative of e to the 5x, it's just going to be some constant times e to the 5x. That's the beauty of the e function. Now, If you have a product of a polynomial times an exponential function, then your y sub p also needs to be a product of the similar degree of your polynomial, ax plus b, times e to the 5x. Now notice here, you don't need another coefficient for that. These two coefficients will be sufficient. Okay? If it's an x squared e to the 5x, you have to introduce an ax squared plus bx plus c. Remember, any polynomial, you have to include all the lower terms as well. Even though this only has 1, this one has 3, and then that's multiplied by e to the 5x. You don't need another one. The c e to the 5x is going to be sufficient there. Okay? Now, if you have a product of an exponential function and a sine or a cosine function, let's just deal with this, then you'll need the sine is going to produce an a cosine 4x plus a b sine 4x, okay? But you're going to have to multiply that by e to the 3x. So just get them all together. A e to the 3x cosine 4x plus b e to the 3x sine 4x. Okay? You don't need a separate coefficient for the e. Let it use the coefficient, undetermined coefficient for the cosine and sine. There's more of them. This one, just like we said before, you'll have to do all the terms here, ax squared plus bx plus c times a cosine 4x times a sine 4x. Again, you don't need a separate coefficient, undetermined coefficient for the sine and the polynomial. Since the polynomial has 3, that's going to be enough. The sine would have only had 2. So you got everything covered there. And if you think about it this way, c cosine 4x plus g cosine sine 4x, that would have covered that anyway if you didn't have that one. Okay, what if you have more product? Okay, well now this one, remember, just like the one we did earlier, would be an ax e to the 3x plus b e to the 3x. Then you multiply that same thing by your sines and cosines. So and they write it this way, ax plus b e to the 3x cosine 4x plus cx plus e e to the 3x sine 4x. Now, that one kind of broke the rule a little bit. Oh, I guess I didn't state it here. Also, it showed up here too. The polynomial here that goes with this, you have to have one for the cosine and a separate one for the sine. Now, it may turn out that some of the a's and e's are the same, or it may be, but they don't have to be. So that's when I sort of glossed over. You need the one with the most number of undetermined coefficients, and that would be 3 for this one. You need that for the cosine and another one for the sine with different undetermined coefficients. Same thing here. This has 2 ax e to the 3x plus b e to the 3x. That's times cosine 4x, and then another set d and c and e x to the 3x and cosine. Now, in reality, you could have put, and you can multiply this out and see it works this way too. You could have just put, nah, let's leave it alone. That's how you do it. Those are a little more complicated. You have to think a little more deeply on those, but that's what you use. Now that is if the particular solution has no component similar to either component, any of the components of the complementary. Okay? So, no, I didn't. Okay. So, let's do example 5. Now, what are we, about an hour and 15 minutes into the class? and we got another about an hour to go, right? I think I'm in favor of a bladder break. Can y'all handle one?
Yes, sir.
Okay, so let's pause the recorder for just a moment here while I go and, all right, I'm back. I think I can make another hour without another break. Okay, let's go. So here's example 5. Let's determine the form of a particular solution for this one. They're not asking us to come up with a thing, just to come up with the form. Y double prime minus 8y prime plus 25y is equal to 5x cubed e to the minus x minus 7 times e to the minus x. So let's go to our whiteboard and see what that gives us. Okay, I'm going to have to, here's the equation. Y double prime minus 8y prime plus 25 y is equal to 5x cubed e to the minus x minus 7 e to the minus x. Now, let's do a quick timeout before we get too deeply into this. And let's see why this is a case 1 problem. Okay, if you look at these coefficients here, your auxiliary equation would have been m squared minus 8m plus 25. All kinds of bells and whistles should go off, because guess what? That is not factorable. So that means you cannot possibly have an m equal 1, no, m equal minus 1 as a solution. It's not going to work. So that's why we can look at this problem and say, hey, we don't have to worry about any duplicating of your characteristic solution. Not going to work. You're going to have to go to the quadratic equation, on the quadratic formula on this one, and I'm almost certain, just looking at it, that it's going to be complex roots. So you're going to have sines and cosines as the answer. But you don't have any sines and cosines on the right hand side, so you're okay. Now, the next thing to note here is that you have common terms here. So I think I would rewrite this as 5x cubed minus 7 times e to the minus x. Okay? Now, what is that going to produce for your undetermined coefficients? Well, this is the biggie here. It's a cubic equation. This is just a simple little exponential. So let's let all the arbitrary coefficients, undetermined coefficients, go into that part. So that's going to be ax cubed. You're going to have an x squared term, bx squared. You're going to have an x term plus cx. And knowing the book, they don't like to use d, so it's going to be plus e, the constant term, because of course you have a constant term. And this is going to be e to the minus x. That should do it for us. Okay, so that should be the form that we would have for the undetermined coefficient, the particular solution. That should be your particular solution. So I should have probably written that down that way because that's what they were asking for. This is equal to your y sub p, okay, with the undetermined coefficients in there. Now we haven't figured out what they are, but that's what will turn out being, okay? And that's the A part. Now, I don't know, it sort of drives me nuts the way they do this. I think it's worthwhile to do the left-hand side. They wind up showing it to you anyway, but why not actually do it? So let's go and take a look at the left-hand side. This, like I said, was going to produce an m squared minus 8m plus 25. And just a cursory glance at that, and that's equal to 0, you know, beyond the shadow of doubt, there is no factorization that's going to produce that. So we go to our quadratic formula, which tells us that m is equal to minus b, that's going to be an 8, plus or minus the square root of, you thought you were through with this, didn't you? La ha ha. B squared, which is 64, minus 4 times A times C. Well, A is 1, C is 25, 4 times 25 is 100. And we know what that is. This is all over 2A, which is just 2. So this is 8 plus or minus okay, 64 minus 100 is negative 36. The negative we take out with an I. The square root of 36 is 6. So that's 6I all divided by 2, which then produces 4 plus or minus 3I. Okay? Oops. I want to make that a unit vector. This is not what it is. It's an I. Okay? Not the unit vector I. So this is your alpha, and 3 is your beta. So our characteristic solution here is y sub c is equal to e to the alpha x, so that would be 4x, times c1 cosine, they always put cosine first, and the beta is what goes there, 3x plus c2 sine 3x. Always it's like that. It's always a plus sign and always sine and cosine with the same arguments, the beta x. Okay? And then you take that and add it to, so I'm going to do away with this thing, plus the thing up here, your particular solution, and that gives you your general solution, the y with no c under it. Okay? Notice here, it does have an e in it, e to the 4x, but that is an e to the minus x up here, so no conflict at all there. This is a polynomial here, this is trig, sum of trig functions there, no problem there. So there's no conflict, nothing to make this a case 2 situation. Okay? Now, that was the A part. Okay? And we did more than they said to do, but it's fine. Let's do the B part. Can I clear now? Okay? I'm going clear. I don't hear an answer. Well, I thought I was going clear. There we go. Now, the B part. Y double prime. If I can read it right. Plus 4y is equal to x cosine x. Now this has potential for issues. Yuck. Okay? And the reason I say that, it's not, but it has potential for it. This is going to be an m squared plus 4 equal 0. Well, obviously, I hope it's obvious to you, that would be an m equal plus or minus 2i, right? Because m squared would be minus 4, m would have to be plus or minus 2i. So the alpha is 0, okay? The beta is 2, okay? Well, we're okay. This coefficient here is 1. This would give you a sine and a cosine with a 2x in it. We're still okay. We're going to be fine. So the question here is, what is your particular solution, which is all we're really interested in. And the y sub p here is going to be, okay, polynomial, and this, both are going to have 2 parts. So let's group them with the polynomial. Ax plus b, because you have to account for every term you could have in it. This is only first order. You have to do the 0 order term, 0 degree term. And then that's times the cosine produces, yuck, get out of there. Okay. Cosine produces a cosine x plus sine x. Now you might ask yourself, why didn't you put the a and b with those, or a c and e with those? You don't need to double do. The one that requires 2 coefficients, this one requires 2. Actually, either place you put them, but they usually put them with the coefficient, with the polynomial. Okay, so that's going to be ax plus b cosine. Oh, nope, right, I said it wrong again. You do need it. Okay, you cannot do that. Sorry about that. Sometimes, well, the eraser's not picking up. There we go. Okay, cosine x, I could have erased this, so let's just say that's out of there, plus cx plus e times sine x. Okay, because, yeah, it basically this becomes your coefficient for your cosine, that becomes your coefficient for the sine, if you'd have had the things in there. But now it's not just a coefficient, it's a polynomial coefficient, which has 2 parts to it. So you do have that one. I was almost swearing they had that wrong. No, with the e you wouldn't need it, but with sines and cosines you do. I'm sorry, that's where I messed up. With sines and cosines you do need both parts. Yeah. All right. Sorry about that. And they don't even give you the total solution there, I don't think. So here's the form rule for, can I go on and clear? Okay. Let's go back to our book. Okay. So here's the form rule for case 1. So there's that one we just did. Now, again, they come up with the characteristic solution, and I already told you that one. There is no alpha, so there is no, alpha was 0, e to the 0x is just 1. So you have C1 cosine 2x plus C2 sine 2x. That neither one of them has the cosine and sine 2x's don't conflict with the cosine x and sine x, different functions. So that's why you didn't need another part to it. Now, if g of x consists of a sum of, say, m terms of the kind listed in the table, one that we showed on the previous page, those were products, remember? Now, sure, in the polynomial they sums, but the rest of them are products, okay? Then the assumption for a particular solution y sub p will be the sum of those trial forms, okay? If that first sum was y sub p1, another sum was y, yeah, and you can have a whole string of these, finite, but you can have a whole string of them, so the particular solution would be the sum of all those. So here's the form rule for case 1. The form of y sub p is a linear combination of all linearly independent functions that are generated by repeated differentiations of your g of x. So whatever is going to produce, when you repeat the differentiations, you know, your y prime, you have so many y double prime, so many y prime, so many y, and you can have cubes and all sorts of things there. You know, you're going to have to cover all the possibilities of those on the right hand side. So continuing then with example 6 here. Determine the form of the particular solution for this differential equation. Okay? And I guarantee you this has sums in it. A difference there and a sum there. So this is going to be combinations of 3 of them. So let's get this done on our whiteboard. Yeah, I think we've got time to do it. Y double prime minus 9y prime plus 14y is equal to 3x squared minus 5 times the sine of 2x plus 8x e to the 6x. Okay, now there's our issue. Okay, now I don't like to be surprised by the characteristic solution, so let's just quickly do that and see what we're going to get. You get the m squared minus 9m plus 14 is equal to 0 when you do the homogeneous case. Okay, now that I think is factorable, isn't it? That would be a m minus 7 times a m minus 2. Correct me if I'm wrong there. Okay, believe that's going to work. Okay, so that means m equals 7 or m equals 2. So your characteristic solution y sub c is going to be c1 e to the 7x plus c2 e to the 2x. That's all you have to do. You found that out. You go up here, you know you're not going to have any signs coming from that because you don't. The e's come from that, but this is e to the 6x, not 7 or 2x. So you're in case 1. You're okay on case 1. So let's now worry about the particular solution, y sub p. Okay? Now I'm going to do it all at once if it's okay with you. The first sum here is a polynomial. It's only a monomial, but it's a second order. So to cover that, you're going to need an ax squared, yuck, plus bx plus c. That covers your x squared. That just covers, where in the world is my cursor? There it is. That covers this part. Okay, this part obviously is going to need a sine and a cosine. So that's going to be a plus. They don't like to use d, so we'll start with e cosine. They always lead with cosine. 2x plus f sine 2x. Okay, that's going to cover this part. Okay, now this part has a polynomial in front with that, so that's going to be plus, I guess we'll continue with g x plus h, because this is first order. You need to have your zero order there too, or first degree and 0 degree, times e to the 6x. There's your particular solution. And none of these are going to conflict with your characteristic. So I think that's how they probably should leave it. Let's see. A x squared plus bx plus c plus e cosine 2x plus f sine 2x plus gx plus h e to the 6x. Good for them. And then they went back and showed you your characteristic solution, c1 e to, they always put the numbers different from me. I put 7x first, and c, I left off the 2 here. Y'all let me get away with it, huh? c2 e to the 2x. They did reverse, c1 e to the 2x and c2 e to the 7x. None of these for the characteristic in any way, shape, or form are going to ever bother any of these, because the only one of the e's in it is that one. This is 6x. These are 2's and 7's. Okay. So any question on that? Now let's clear these and go back to the book. Okay. Sorry, I know we're almost, I've got it, I'm awfully dry. I know in some circles red Solo cups mean one thing. That's not what they mean here. So anyway, we'll leave that alone. Okay, let's move to case 2. Case 2, the function of the assumed particular solution may also be a solution of the associated, or at least a part of a solution of the associated homogeneous differential equation. If that's the case, we're going to have to add an x, basically, is what it gets down to. So here's the problem, example 7. A particular solution here of this one. All right. Let me see if I can. Oh, one reason I need to flip the page. That's why I couldn't see what was going on here. Okay. So let's go back to our board, whiteboard. All right. Find the particular solution for this one. Y double prime minus 2y prime plus y is equal to e to the x. And they sort of picked a interesting one for you to do here. Now, I don't like to let's guess a particular solution and then see it doesn't work. Let's make sure the characteristic does work. So the characteristic solution will start with the auxiliary equation to start the process, and for some reason I cannot get the pen. There we go. All right, that will be m squared minus 2m plus 1 is equal to 0. That's when you do the homogeneous equation on the left hand side, make it equal to 0. And I hope you see this is going to be m minus 1 squared. So your m is equal to minus 1. But it's a repeated root. So what would that lead your characteristic solution to be? So y sub c would then be c1 e to the, okay, I'm sorry, I said that wrong. Y minus 1 equals 0, so y is equal to plus 1. That's your repeated root. Okay, c1 e to the x. And you can't do another c2 e to the x, so your second one has to be, and this was case 2 of the homogeneous kind, okay, back in the last chapter. Okay, so this is c2 x e to the x. Okay, well, this is obviously shows up here. So you can't just multiply an x by it because that then shows up here. So your particular solution, y sub p, would then be a x squared e to, yuck, got away, okay, x squared e to the x. Now, the question is, would you need to go back and do a linear and a constant term with that? No, you wouldn't, because they are showing up here. So that's all you need. There is your particular solution. Okay? If I can find my problem here. Okay? Oh, I'm on the wrong page. No wonder I was finding no answer that made sense. Y sub p is a x squared e to the x. That would be your form for it. This one, they're saying let's actually carry it through and see what we get. Okay, so what we're going to do here is do a y sub p prime. Take the first derivative of that. Whoa, product rule, right? If you do first time derivative of the second, that would be an a x squared e to the x, because the derivative of e to the x is e to the x. Okay, ax squared e to the x plus other half of the product rule would be a 2ax e to the x. Okay, now y double prime, y sub p double prime would then be two product rules. Okay, the first one would be a x squared e to the x plus, just like before, 2 a x e to the x plus, and this one will give you first time derivative of the second, another 2 a x e to the x, and then I've run out of room. The last one would have been a plus 2a e to the x. All right, now these two can add to be a 4 here. All right, so let's write them down that way. Your y double prime would be a x squared e to the x plus 4ax e to the x plus 2a e to the x sure I'm right there, I believe so, minus 2 times y sub p prime. That would be minus 2ax squared e to the x minus 4a x e to the x plus your y prime, which is just a plus y sub p, which is plus a x squared e to the x. All those added together are supposed to equal e to the x. That's what your original thing said. So it's pretty obvious that your x squared e to the x's better add to 0. Well, here you have an a minus 2a plus a. Well, it's plus 2a minus 2a. Those indeed add to 0. All right, that's done. Your e to the x's, x e to the x's should add to 0, and sure enough, they do too. A plus 4 and a minus 4. Those add to 0. So what we're left with is a 2a e to the x equal e to the x. So 2a is equal to 1, meaning a is equal to 1/2. All right. So that gives you your particular, is what they're asking for. Find the particular solution. That would be y sub p is equal to x squared over 2 e to the x. And is that how they write it? They write it as 1/2 x squared e to the x. That's it. Okay? Now, clear this. Does anyone need it a little longer? So let's clear the drawings. Okay, and go back to the text. Okay, and that shows the solution we just got. Y sub p is 1/2 x squared e to the x. Now they go up. We suppose again that G consists of m terms of the kind given in table 4.4.1. That was that whole list of things there. Now, every one of those terms could be one of those forms in the table. Well, then every one of those terms would have the potential y sub p1 to be some linear combination of the first deal, the second one, the third one, the fourth one, all up to the mth one, if they have m of them. Okay, those are the trial particular solutions corresponding to those terms that we had. Now, under the circumstances described in case 2, where one of those particular solution is also a form of your characteristic solution, here's what you do. If any y sub p sub I, okay, any one of those, okay, contains a term that duplicate the terms in one of your y sub c's, then that y sub p1 must be multiplied by an x to the nth, where n is the smallest positive integer that eliminates the duplication. Remember, up here we had an we had a e to the x and an xe to the x. So then for our particular solution, we needed an x squared e to the x. So because we had to eliminate any duplication in your characteristic solutions. So that leads us to example 8, which also happens to be an initial value problem. Let's see where we go with it. Okay. All right, let's go to our whiteboard. Okay. Oops. Pick up the wrong thing. Okay, here we have a y double prime. Looks familiar, doesn't it? They can be third order, fourth order, 15th order. Hopefully we won't have many of those. Plus y is equal to 4x plus 10 times the sine of x that's your differential equation. Your initial values are, you need 2 because it's second order differential equation, y of pi is equal to 0, but we also have that y prime of pi it'll disappear in a minute. Y prime of pi, and it took off my hat. Okay, y prime of pi is equal to 2. Okay, I like to put semicolons here. They put commas. Those to me are not strong enough. Semicolon between the differential equation and the initial conditions. Comma and the initial conditions are fine. It doesn't matter. There's no rule for that, but I just like to do it. All right. I think in this case we'd better do the auxiliary equation, which of course is y or m squared plus 1 is equal to 0, which means m squared is equal to minus 1, which means m is equal to plus or minus I. Okay, now notice here your alpha again is 0, that's the real part, that's equal to 0, and your beta is your 1. Okay, so with that in mind, you know the characteristic solution y sub c is going to be c1, they always write cosine first, cosine, and there is no e to the alpha x, that's e to the 0x, that's going to be 1. Okay, cosine x plus c2 sine x. Whew. Goodness, I'm getting hungry. Okay, sorry, I shouldn't be, but I am. I've got another class to go. On Mondays and Wednesdays, I have to eat at 10:30, which is right now. And on Tuesdays and Thursdays, I have to wait till 1:15 because I have 2 morning classes. Okay, or one over the middle of the day. So my stomach gets used to one and doesn't want to wait. Okay, now here we see a potential problem. Here we have a c2 sine x here we have a 10 sine x there. Obviously that's going to be an issue for our particular solutions. So let's write down what the particular solution has to be. Okay, so y sub p will have to accommodate first a linear polynomial, which of course would then be and AX plus B plus a one with sines and cosines in it. But you just can't have a sine and cosine because you have the sine down here as well. So this one we're going to have to do plus CX cosine X plus, they don't like D, so we'll use the EX sine X. Okay, the second part here requires a cosine X and a sine X, but because you have a sine X here, you have to multiply the lowest degree of X times it so there's no conflict. And now we have it. So example 8, that's what they show. Your y particular is AX plus B plus C cosine. Whoa! No. They are going through and saying, but that won't work. So the actual y sub p is AX plus B plus CX cosine X plus EX sine X. Got it. Now we have to differentiate that particular solution. So y sub p prime is equal to A, B goes away, plus first time derivative of the second is actually going to turn into a minus then. Yuck, this sorry thing. No, it's erase. That's what I want. It erased the whole thing. It's better than not erasing it all. Minus, because you have the CX, derivative of cosine is minus sine X. That's where the minus sign came from. Okay. Then the other half of that would be a plus C times cosine X. Okay, that's the first part of this one. Then you have a plus EX times the cosine of X plus an E times the sine of X. Whew, there's YP prime. Okay. Now, we've got to do YP double prime. I'm going to start over here because I'm afraid it's going to be long and messy. Okay. First, the A goes away, so you don't have to worry with that. So when you do that first one there, you get a minus CX. It should be a capital C, but I made it too small. Cosine X minus C times sine X. Okay. Minus another C times sine X. Okay. So that really makes two of those. So I'll go on and write that and erase the second one just to keep from running out of room. So I've accounted for that one then. Plus, well, let's make it a minus, EX times the sine of X plus E times cosine of X. That's the second part of the product rule for that term. And then the last part is going to be another plus E sine cosine X. So there's going to be two of those. So maybe I didn't need so much room, but it's sort of nice to have it. Now that we have those, we're going to plug them into our original equation. And that's going to be minus cx cosine x minus 2c sine x minus ex sine x plus 2 e cosine x. Whew, okay. No y prime terms. We had to take it anyway, but now plus, so it's going to be a little bit easier to write, plus your y term, which is just y sub p, is ax plus b plus cx cosine x plus e x sine x. Wow. Okay. And all that is supposed to equal the right hand side, which is a 4x plus 10 sine x. This is aggravating how it won't write. Okay. Sorry, I'm getting awfully dry. All right. Now, let's start with the x. There's only one x in the upper one and only one x in the lower, in this right hand side, so that gives us a is equal to 4. I hope. That's this term and that term. Okay, let me make sure. Yep, a is equal to 4. Sorry, wait just a second. All right. Now, the only constant term we have here is b, I think. Yep, and I think b has to be 0. Okay, so that's going to make it easy. The b here has to equal 0. So b is equal to 0. That will be nice. Now, let's do the sine x terms next. Well, let's just verify and make sure everything's working out. You have no x cosine x terms here, so here we have a minus c x cosine x. Here we have a plus 2e, I hope that's an e, cosine x. Here we have a minus c, a plus c, so those two get rid of each other. And here we have e cosine x, and I don't see another e cosine x. Now, did I leave something out? I don't think so. And since there's no, wait. We're doing x cosine x's, yeah. They're okay. Done. That's the only x cosine x. All right. That was a little bothering at first, but I think it's okay. Then let's do this sine x. Okay, here we have a minus 2c. That's yours with your sine x. This is x sine x. There's the cosine x, and there's the x sine x. So, and by the way, we can just wipe these out right now. One's a plus and one's a minus, so they go away. Okay, which they should. And here we have 2c minus 2c is equal to 10. Because minus 2c sine x has to equal 10 sine x. So minus 2c equal 10. C is equal to minus 5. Let's see if the book got that right too. See if I can find it. C is equal to, what was C? Yeah, was minus 5. And we got that right too. B was 0. Let me make sure it was. B was the constant, and there is no constant in it, so that's good too. Okay, now, so we've taken care of this term and this term. Okay, what we have left is 2e cosine x is equal to 0. So obviously e has to be equal to 0. Let's see if that's what they get to. Yeah, e is equal to 0. A is equal to 4, b is equal to 0, c is equal to minus 5, and e is equal to 0. Got it. Good for them. Okay. So what does that leave us with? 2 minutes. Okay. Let's write down our solution. Y is equal to C1 cosine x plus C2 sine x plus 4x. B is 0, C is minus 5 x cosine x, and E is 0. Okay, so there's our general solution. Now I'm going to have to erase some stuff, and I'm afraid I'm going to be out of time really soon here. So let's erase this because this is in the way and we don't need it anymore. And erase this because that's in the way and we don't need it anymore. In fact, let's erase all this because we don't need it anymore. We don't need a lot of it, but I'm going to just get all the stuff around here that is messing with the situation here. So it's a bit more obvious, I hope, what we're going to be doing here. Okay, I think that's all I need for now. But we have initial conditions, so let's plug those in. So y is equal to 0 when x is equal to pi. So that would be 0 is equal to, can anyone recall what cosine of pi is? -1. Cosine of 0 is +1, pi halves is 0, pi would be -1. So you got 0 is equal to, well, sine of pi is 0, so we can't get anything from that one, plus 4 pi when x is equal to pi minus, and cosine, remember, of pi is -1, so that's going to make a plus 5 pi. X equal pi. So what we have now is that C1 is equal to 9 pi, I think. Let's check and see if that's what they got. C1 is equal to 9 pi, and sure enough it is. Now, with that in mind, let's plug, goodness gracious. We need to know what y prime is. And I'm out of time. But it's pretty easy to do, okay? You take the derivative of this, y prime, and that's going to be a minus c1, but we know what c1 is, so it's a minus 9 pi cosine or sine x plus c2 cosine x plus 4 minus, and then you have a product rule here. So we got a little bit to go. So let's just say we will pick up at y prime next time, okay, and we'll go from there. Okay, sorry about that. I had hoped to finish that problem, but it's with the initial value, it's going to take a little longer. Let me give you homework exercises here. I think you can do any of the odds 1 through 25. And I think you can start doing some of 27 through 35. Okay? We'll hold off the rest of those until next time. Okay. Any questions? So please, folks, get your research papers into me today if you haven't gotten them in already, or early as possible if you can't get them to me today. Get your first and second test into me today, tomorrow, or by Wednesday, if at all possible. No, tomorrow is Wednesday. Today, tomorrow, or by Thursday if you can. Please try to get that done. And then I'll be giving you the last test on Thursday afternoon, and then you can start working on that and try to get that to me back to me either Thursday, which would be amazing. Friday would be great. Saturday would be okay. Sunday, you got to have it into me by Sunday, okay? So I can get it graded and figure out your grades and get it out there on Monday. Okay. Any questions? All right. Let me end the sharing because I'm tired of sharing. Any questions?
No, sir.
All right. Then we'll end the meeting for all. We'll see you on Thursday.